Okay, today's topic, we're going to continue with arithmetic sequences, but we're going to figure out what a series is now and how they're similar and so on. So, for example, you can see this guy's going up the stairs. So we can see that our first stair is at 0.3, and we're going up by 0.3 each time. So if we just were to actually list out our terms, we'd have 0.3, 0.6, 0.9, 1.2, and so on. But basically the series then would tell us how far up we actually went. So instead of just listing the terms, we're actually going to be adding or subtracting them. That's basically the main difference. So let's quickly review some of the key formulas that we were working on. So if we have our sequence 3, 5, 7, we're looking for term 8. Remember, we'd have term 1 is 3, and our D is 2. So we could actually just plug that in. So we'd have 3 plus 2 times n minus 1, so 8 minus 1 is 7. So we'd have 3 plus 2 times 7 is 14, which would give us 17. So pretty basic formula. Our general term would be the same thing, except we don't know what term number we want, so we just leave that out. So we'd have 3 plus 2 times n minus 1. We could leave it like that, or we could actually FOIL it out and simplify it a little bit. So we'd have 2n plus 1 would be our final answer. And the last one is 50, a term of the sequence. So remember, we put 50 in as our t of n, and we actually see if we actually get a whole number for n. So if we subtract 3, subtract 3 is 47. 47 divided by 2 gives us a decimal, so that's a pretty good hint that it's not going to work. If it was 48, we'd have 24, so we actually get 23.5. n minus 1, so that would give us an n of 24.5, which doesn't work because our n has to be a whole number. So our answer for that one would be no. So, like I said earlier, what we're going to look at today now is the same sort of idea, except we're going to be actually adding them up. So depending on the topic, sometimes we don't want just know what the terms are, we actually want to know what the total would be if we were to add all these things up. So you can see this first thing, our example of our sequence is what we were looking at before. 5, 8, 11 is a sequence. Now if it's a series, we'd have 5 plus 8 plus 11 plus 14 and so on. We still use our basic formula to help us to find out what our D is or what our missing terms are or number of terms, things like that. But now we're going to use one of two sum formulas. So this first one you can see, we say the sum of whatever number of terms is n divided by 2 times t1 plus tn, or we can expand it out a little bit. So you can see this is first term plus last term, and we divide that by 2 and times it by the number of terms. But sometimes we don't know the last term, so we can actually put our t of n formula in. So if we actually put in t1 plus d times n minus 1, you can see that's where that second formula comes from. So we find the tn first, plug that in, so we get 2 times t1 in our other formula. So either one works, we just have to, depending on how the question's given to us. So the first one, it says determine the sum of all of these numbers. So our formula that we want to use is n over 2 times t1 plus tn. The reason why this formula works is we can actually write these numbers backwards. If we actually list all of these numbers backwards, like that, and we actually add up each row, so 75, negative 75, and negative 45 gives us 120, negative 120. If we add these ones up, we get negative 120. Add these ones up, we get negative 120, and so on. So what's weird about a sequence is we actually get the same totals. So that's why we get the t1 plus tn. If we add the first and the last together, that gives us the negative 120. And we just have to divide by, or times up by the number of terms. So 1, 2, 3, 4, 5, 6. So 6 times 120 would be our sum. But we added the two rows together, so that's why we divide by 2, because we don't want the total of 120. We actually only want 60 times the 6. So in this case, we'd have 6 divided by 3 is 3 times 120 should give us negative 360. So if we actually were to list all of these numbers and add them up, so we could try it if we wanted to see if it actually works. So if we go 75 and 69 and 63, if we add all these up, we do get 360. Negative 360 is the correct answer. So it's kind of a trick formula, but it's pretty easy to work with. The second formula works the same way, except we don't know the t of n. So that's why I said you can either find it first, so use the old formula and then do it just like we have above, or we can put the two together and get it all in one calculation. So you'd have 2 times t1 plus d times n minus 1. So if we plug all that in this case we want the 10th term, so we'd have 10 over 2. Our first term is negative 75 still. Our d is, we're going up by 6. And we want 10 terms, so 10 minus 1. So simplify all of that. That gives us 5 times negative 150 plus 54. So negative 150 plus 54 is negative 96. And times that by 5 gives us negative 480. Okay, so if we actually do all 10 terms, we'd get 480. So you can see the first 6 terms was 360. Now 10 terms gives us negative 480. So the two formulas are pretty simple. You just have to work with it. So the next one, we see we got our first term, we got our last term. So we should be able to use the shorter formula. So we'd have n over 2 times t1 plus tn. So you can see we have our first term, we have our last term, but the problem with this case is we don't know the n. Right? We have our total sequence, but we don't know the n. So we're going to have to go to our old formula first and solve for n. So let's do that. So our last term is 33, our first term is negative 75, our difference is 6. We're going to solve for n. So we'll go 33 plus 75, that gives us 108. So 108 divided by 6 gives us 18. And we'll add 1 to both sides, gives us 19. So now that we know n is 19, we can actually figure out our total. So 19 over 2, negative 75 plus 33. So we get 19 over 2 times negative 42. And we work all that out, we get negative 399. Okay, so if we are actually to continue this list of numbers, add them all up, we would get our negative 399. So it works pretty good, but the only real tough ones like this is when you actually have to do the t of n first to solve for n. Because no matter which formula we use, we need to know the n. It's n over 2 times the rest. Okay, so here's another one. We've got a series as S20 is 410. We've got a difference of 3. We have term 20 is 49. The question's asking, what are the first 3 terms? So you can see if we were to look at our Sn again, let's use the easy formula. And let's plug in everything we know. So we're going to call, both these are 20 terms, so our sum of the 20 terms is 410. So let's put that in for Sn. We know we have 20 terms, so 20 divided by 2. We don't know term 1, but we do know that the last term is 49. So we can actually solve this for term 1. So we'd have 410 equals 10 times term 1 plus 49. So let's divide by 10 first. So 410 divided by 10 would be 41. So 41 minus 49 would give us negative 8. So we know our term 1 is negative 8, and they're telling us our d is 3, so we add 3, so that gives us negative 5. Add 3 again gives us negative 2. So those are our first 3 terms. So just like we did before, we can work with the Sn to solve it for t1, solve it for tn, things like that. So here's a couple more word problems and then we'll stop here. So it says a pyramid of cans has 10 rows. It says the bottom row has 100 cans. So we know our term 1 is 100. Each row above it has 5 fewer cans. So then we'll go 95, 90, and so on. And it's asking what are the total number of cans in the pyramid. So we want to find Sn. We don't know the last term in this case, so let's use 2t1 plus d times n minus 1, and we should be good. So we're looking for our total sum. We know our n is 10 rows. We know our first term was 100, so 2 times 100. Our d is minus 5, and our n was 10, so we did 5 times 9. So if we simplify that, we get 10 over 2, which is 5, 200 minus 45. So we'd have 5 times 155, and that should be our final answer, which is 775. Okay, the last one says the sum of the first 4 terms is 60, the sum of the first 5 terms is 95. It's asking what are the first 7 terms. So this one's a little bit tricky. Let's think about this a little bit carefully. So we know the first 4 terms, we don't know what they are, but we know they're going to add up to 60. And then if we add one more term, we know it adds up to 95. So that means our last term from 60 to 95, we know that that term has to be 35, because if the total of those is 60, we're only adding one more to get to 95. That means the difference would then be that 5th term. So we know term 5 is 35. We know the sum of that is 95, and we know our common difference. So we should be good to go. We should be able to solve for term 1. So let's use our longer formula again. And let's see if we plug everything in. So we know our last term, our sum of our terms is 95. And we know that's 1, 2, 3, 4, 5. So we know we have 5 terms. We don't know term 1, so let's leave that. And we know our difference is 8. They tell us that in the question. And we have 5 terms, so 5 minus 1 would be 4. So we can simplify this. We'd have 95 divided by 2.5 gives us 38 equals 2t1 plus 32. So let's subtract the 32. So we get 6 equals 2t1. So that means t1 equals 3. So if we know that term 1 is 3, we know our common difference is 8, so we should be able to fill in all of our numbers. Let's use different color here. So we'd have 3 plus 8 is 11, plus 8 again is 19, plus 8 again is 27, plus 8 is 35, so we know we got it right. And we want 7 terms, let's just do 2 more. So 35 plus 8 is 43, plus 8 again would be 51. So there's our 7 terms that they're asking for. And that's it. So you can see a couple new formulas, but we're dealing with sums instead of just listing the terms, but they both formulas work together often.